the textbook thinks that it covers it in the other lessons, but Mrs. Pilney and I over the years have felt like it's not covered well enough. So we just throw in this 1 day sort of added assignment, which is why we don't cover it in 2 days. We do notes and homework just right in 1 day like this, okay? Which isn't our usual vibe. All right, so call this linear equations 3 forms. We just don't feel like the textbook does a great job of filling all of this in, and we think that if you understand this topic really well, you will be able to really do well on the MCAs. All right. So the first thing is there are 3 forms of the linear equation. There's slope-intercept, right? Standard form and point slope. Those are the 3 forms. And what I've discovered is the kids who can manipulate back and forth between those 3 forms are the kids that are typically more successful on the MCAs. They're the ones who can say, if they force you to look at a standard form equation, but you don't like standard form, and you can turn it into slope-intercept, you're going to be more successful on the MCAs because you can make it be what you want it to be more often, okay? So that's what I'm going to teach you how to do today. I'm going to teach you to make it be what you want it to be for your own benefit. There'll be times when you can't really manipulate it, but the more you can, the more you turn that test into your test, right? So let's start by writing slope-intercept. Slope-intercept is the one that looks like y equals mx plus b. Anytime you want to make something look like y equals mx plus b, the key thing you need to remember is just to isolate y. Man alive, those fans are loud. All right. So if I gave you this equation, 3y minus 2x equals 12. And we take a close look at y. That's what we want to isolate right there. The first thing I want to do is get rid of this 2x. I don't want to separate the 2 and the x because that'll leave x behind. I want 2 and x both out of the way. So what do I do to get rid of them? Yeah, so I'm going to add 2x here, and I'm going to add 2x here. Now, 12 and 2x cannot be added together. They're not what you call like terms. So while this 2x and this 2x now, they're gone, right? I now have 3y equals. Just to make this look more like mx plus b, I'm going to put the 2x in front of the 12. I'll say I've got 2x plus 12. Those two can't go together and make, say, like 14x, right? It looks to a lot of folks like this y is isolated, but remember, that y right there is not isolated until the 3 is gone, okay? The 3 has to be out as well. What's up, Clayton? So what do I have to do to get that out, Clayton? What's the opposite of multiply, though? Yeah, so I would want to divide. And you can write it like this and say divide like that. You can say I'm going to divide everything by 3. And when you do that, you just want to be really careful now to don't forget that that's going to affect this 2. That's going to get divided by 3. But so is the 12. Both of these will be affected by that division separately. Now, when you have division going on and you're like, okay, so 2 divided by 3, and you stop and think, I want to grab my calculator and find out what 2 divided by 3 is. Don't do that. Just like it's a fraction, it's 2/3. Just let it be 2/3. Don't don't mess with anything. Like, I think sometimes we make more work out of stuff. If we would just accept the fraction, it would be life would be easier. Just let it be a fraction. It's 2/3. It's rise over run. Let it be that. And what is 12 divided by 3, everyone?
4.
Yeah. And so we have 2/3 x plus 4. Watch your signs up in this kind of world right here. I have a tendency to drop my signs. So like if you had -12 over -3, that would be positive. If you had -12 over 3, that would be -4. Really watch your signs in this game because it's easy to lose them. This right here then would be your answer. And what's kind of funky is that this equation right here and this one right here, they're exactly the same if you graph them. They look totally different. See, they look totally different, but they're exactly the same equations. You just manipulated one to make it look like this one here. Now, we can also have an equation like this one. And this one, I showed you one kind of like this the other day. So write y minus 2 equals 4 times x plus 3. We sort of talked about one like this yesterday, I think. So you might remember the first step on this one. What do you think I should do first? Yep, distribute. So I'll take 4 times x and 4 times 3. So I'll get y minus 2 equals 4x plus 12. And remember, I'm trying to get y alone. And I'm trying to get y alone because I'm trying to make this equation. That's the only reason why. It told me I'm trying to make a slope-intercept. So now I'm just going to add 2. I'm going to add 2. I divided here because they were multiplying. Or it was multiplying, not they. It's not like someone was there doing it. It was a multiplication. I divided to undo. It's subtracting here. I'm going to add to undo. Yeah.
Why with division do you divide like both the numbers and addition, subtraction, and just do one?
That is an awesome question. So here, when I am dividing, you can divide as like a free-for-all. Adding, you can't, because when you add and subtract, you can only add and subtract with like terms. There's like this rule with adding that you can only add and subtract with like terms, and that's why it only affects these two. But division, you can cut up anything, and so that's why when you divide, it's everybody is affected. Same thing with multiplying. Everything would be affected, and you would multiply with everything. But when you add, it's only the like terms. It's a good question. So then you'd have y equals 4x plus 14. And then that would be your answer where you took a point slope and you turned it into slope-intercept. Yeah. Like if you divide it by 4 here?
No.
Okay. Because you could, like if instead of distributing, you can divide by 4 to like get rid of that 4. That is possible. It would sure make a mess over here though. It would kind of create fractions. Yeah.
If you like add y equals 4x plus 14, and when you divide by 4, would you still get it wrong?
Oh, you would, because here's why. It would create some fractions right here. So like if you took and made this extra step and then divided by 4 after that, like right here, there would be a divide by 4 there. And y would then no longer be alone. And that's why it would be wrong. Not because it would be incorrect to mathematically do. Like there's nothing wrong mathematically with what you did. You didn't do what it said here though of isolating y. That's why. But the algebra is not wrong. All right. That is going to be the first, let's see, like 6 problems you do in your homework today. Okay? Then you're going to have a set where instead of turning things into slope-intercept, you turn them into standard form instead. Now, standard form is the one that's got all the kind of putsy rules. Everything's got to be an integer. The first term has to be positive. There's kind of some rules that you have to remember, okay? So let's write that out. Standard form And standard form looks like ax plus by equals c. And you want to keep in mind that you want to get x and y on the same side. Now, when I say on the same side, I mean like on the same side of the equal sign, okay? So I'm going to put a little equal sign here in parentheses. That's what I mean. So you want them on the same side of the equal sign. Doesn't matter if it's the left or the right. This shows the left, but they can be on the right. And the other thing is, you want there to be no fractions or decimals. To get rid of a fraction, you multiply by the denominator. To get rid of a decimal, you multiply by like 10 or 100. You multiply by 10 or multiply by 100, and that'll get rid of decimals because they're tenths, hundredths, and thousandths like that. Okay? All right. Let's do one that's kind of an ugly problem because you might see one in your homework that is. So we'll do like the worst kind in the notes. There'll be easier ones in the homework maybe, but you want to go through a terrible one and get help on those ones. So we'll see y plus 1 equals 2/3 times x plus 4. So I've got a little bit of everything that's all kinds of wrong going on here. All right. So the first thing I would do is I would distribute. And if I'm honest, that might not be the first thing I would always do. Sometimes I would get rid of the fraction first, but I'm going to teach you to distribute first. Because that can get kind of messy if you don't. Now, when you distribute a fraction, I want you to keep in mind that this is like 1/1, and this is like 4/1. Okay? So when you distribute, you're taking 2 times 1 and 3 times 1. So this makes 2/3 x. And when you distribute, it's 2 times 4, which is 8, and 3 times 1, which is 3. So don't get all nervous when you distribute a fraction. It's numerator, numerator, denominator, denominator. Distribute the top and the bottom. We still have y plus 1 hanging out over here. Now, before you go freaking out and thinking, oh gosh, now I got to take 1 away from 8/3 and that's going to be a problem, you don't, because remember, we're making standard form right now. My next move is to get the fractions out of here. Do you remember how to get rid of a fraction? You multiply by the denominator. So I'm going to take everything and I'm going to multiply. Now, the reason why I multiply by the denominator, if you're looking for a reason, what does this mean right here when you see a fraction bar? Mathematically, divide. And the opposite of divide is, that's why we multiply. So I'm going to multiply by 3. Now, the reason why I multiply this side by 3 is to get rid of these 3's. The reason why I multiply this side by 3 is because I have to keep everything equal. So this is going to be, and I'm going to skip a line just because I'm writing really sloppy right now. So this is going to become 3y plus 3. And then over here, it's going to be like, this is a 3/1. So it's going to become 6/3. What's 6/3? 2. And there's an x. And this is going to become 24/3. 8. In other words, it just gives you back the numerators. Fractions are gone. Now, put a box around that x term because that's going to be your key decider for your next move. And ask yourself, is it positive? Is it positive right now?
Yes.
So if it is, because remember, you need A to be positive. If it's positive, then leave it where it is and bring y over to meet it. Here's why. Let's bring y over to meet 2. Because if we bring 2 to the other side, we're going to turn it negative. So let's subtract 3y from both sides. That's going to get rid of this one. And it's going to leave 3 behind. And we're going to have 2x minus 3y plus 8. Now there's a whole pile of stuff over here. Oh man. There we go. I really needed the x and the y hanging out over here. I didn't need that 8 over there, but it was there already. How do I get rid of it? It's already subtract. Oh, it's added. Dang it. I really messed up. Now I'm going to subtract. And I'll have 3 minus 8 is negative 5 equals 2x minus 3y. Now, if you ever have a negative x and you're like, oh, shoot, I moved it. Now I turned it negative. Take your entire equation times negative 1. We did that before, right? Take everything times negative 1. It'll change everybody's sign. You'll be good to go. I'm going to show you one that's wicked easy, though, but it's where x is negative, and I'll show you how to turn it positive, okay? So write this one down. Go y equals negative 2x plus 1. Notice how there's no fractions to get rid of. Nice. No distributing. Nice. But notice how you don't have x and y together, and x is negative. So to turn it positive, boot it over to the other side. Jacob, pick your head up now. You're going to put it over to the other side. So you're going to add 2x, and you're going to add 2x. Can you add 2x and y together? No. So you'll say 2x. This y is hanging out here, right? It's positive, so this will become plus y. This 1 is just going to drop down. If it said minus 1, I would say like negative 1. All right. I'm going to turn the page because I ran out of space. The last thing you'll see in the last section of your homework is turning stuff into point slope. Now, point slope is the equation that looks kind of gnarly, but it's not too bad. It just looks like it's a lot. But it's really just a point and a slope. It's really not that wild. So all you need to do is find a point. And when you're working with all the equations that we have, the point you're going to find will be this one, 0, blank. You're going to find the y-intercept, okay? And you're also going to find the slope. So the equation that's going to be your best friend in this section of the homework is going to be the one that has the y-intercept and the slope. It's going to be this equation right here. Y equals negative 1/2 x plus 2. That is going to be your best friend because it contains the two things you need. It contains a point, 0, 2, and it contains a slope, negative 1/2. And they're the only two things you need to be able to write this right here. Because you need to plug in a number here, and here, and here. And all three of those things are sitting right there. So you would say, all right, I've got my y sub 1 and my x sub 1. So I'll say y minus 2 equals negative 1/2 times x minus 0. And leave that 0 in there because you want this thing looking like point slope. You don't want to be like, just throw an X there and simplify it out because then it's not going to look like point slope. It'll look like something weird. And that's your answer. So this equation right here, that's your best friend. The one that is not your best friend is this one. 3x plus 4y equals 8. This one's not your best friend because it doesn't tell you the slope, right? Remember that? And it doesn't give you a point. It's kind of a bummer. However, we can force this equation to look like that one, right? So what we're going to do is we're going to change to y equals mx plus b, and we're going to make it be our best friend. What would you do first? Huh? Clayton. Subtract which one? 3x. Yeah, why would I subtract 3x? Which one do I want to get alone?
Wow.
Yeah, so I want to get everything away from y. So I'm going to, because I need to get that y, that 4 away from the y, but I'm going to use division to do it. Not subtraction, because it's multiplication happening here.
Couldn't you just start with dividing by 4?
I could, but I like to do the order of operations backwards. I like to always undo the addition and subtraction and then undo the multiplication and division. Totally could start with division though, I could. But remember the rule with divide, everybody's got to be divided. So don't forget to divide this guy by 4 as well. So then you'd have 4y equals negative 3x plus 8. I don't know why I decided that that was a guy and not a girl, but I did. Okay, I was like, divide that guy. And then I'm going to divide by 4. I was being sexist. And then divide by 4. Now, when I divide this by 4, remember what I said about your signs. When you divide this by 4, first of all, does 4 go neatly into 3? So this is going to be y equals negative 3/4 x. Don't try and put that as a decimal. It's not helpful in slope-intercept, right? Yeah.
Why can't it, or could it be, so like 4y equals 8 minus 3x? Or just
Yes, it can. It can. I always like to make it look as much like this, though, as I can. But yeah, because this is a plus sign, right? And the commutative property says those two could be flipped around, so you could. Then we have to take the 8 and the 4 and divide them. What's positive 8 divided by 4? 2. So then this is, I have a 2 sitting here. What sign should I put here? Plus, because it's a positive 2 is my answer. Had it been a negative 2, I'll say minus 2. Is this my final answer right here? No, because I'm working on a point slope answer. So my point is 2. My slope is negative 3/4. So y minus what? Equals times x minus 0. By the way, this will be the same number on every single problem because of the way we're doing them. Jean.
So is
All right, never minding. No graphs today. 0 graphs. Because I'm not, like, when you work with this guy, you always have to graph with 0 blank, blank 0. But notice how we're working with this guy and we're not doing that 0 blank because we're not graphing. Now, this is a worksheet that doesn't have K and G on it, so you have to do both sides. But you're only doing the evens today, okay? So you're going to get it and you're going to cross off the odds column. I don't want you, we're only working for one day, so it's just the evens. Huh? I can. I thought I'd just let you guys use your notes and just tear it up because that just, I kind of set you up. I thought, you don't want me talking. It's up to you. If you want to 15 minutes. If you want to just throw some music on and your headphones, go ahead. If you want me to check some of your problems, let me know. If you do a couple and you want me to just look and let you know if you're doing them right, give me a holler, okay?
Sorry.
Evens, yeah. I don't know why. I should have done odds because that's what it says on the bottom, but I decided evens and put that on the website, or my Google Classroom. Nolan, can you come here for a minute?